example 18. Same as we did before, we're going to look at sequences that don't have all the terms there, and we're going to have to find the first term. So I'll show you how to do that on this one. Same directions, find the specified term. So, same directions to find the specified term. And we are given the third term to be 24, and the fifth term to be 2,400. And we are asked to find the ninth term. Okay? So the first thing that we did with arithmetic sequences was took the difference between the later number and the earlier one. But that was because we were adding things each time. In this case, we are multiplying each time by a common ratio. So what I'm going to do is I'm going to take the later term and divide it by the earlier term. And this will eventually help me get R. So I'll have 2,400 divided by 24, and that equals 100. So this is the first part, getting R. The second part is seeing how many terms were in between, and in this case 5 back to term 3. That would be 5 minus 3, which is 2. So 2 terms are in between. Actually, 1 term is in between, but it's 2 terms back. And then the next thing, the way I get R is by going R equals the square root of 100. This 2 right here goes here. It's an arrow. And I'm going to connect it. Look at that. Woohoo! That's an arrow. So that's where that 2 came from. This 2 goes here. This 100 goes here. Maybe I'll highlight that in green. Pink. Pink. I like pink. Pink better. And this pink goes right there. Okay? So that's how you get R. You take the whatever root it is between the terms. If you had, say this was 8 and this was 3, you would go 8, 7, 6, 5. And so you take the fifth root. And I'll write that up in the steps. This equals 10. So R is 10. Let me just write that. R equals 10. We have 10. We have R. Now we can use it to go backwards from our third term. How many terms back do we need to go to get to the first term? Because we need the first term. Let's see. If we're at term 3, go back 2, 1. We needed to go back 2 terms. So what I'm going to do, instead of multiplying by 10 to go forward, I'm going to divide by 10 to go backwards. So I'm going to start out at term 3, which is 24, and divide by 10. That's 1 time. And that gives me 2.4. And then I'm going to take that, 2.4, and divide by 10 another time. That's another step backwards. That will give me term 1. So that equals 0.24. So term 1 equals 0.24. Now I can write out my formula and find the ninth term, because that's what my whole goal was. So let's do that. T sub n equals the first term, which is 0.24, times r, which was 10, to the n minus 1. And I'm going to use that to find the ninth term by plugging in 9 for n. And I'll have 0.24 times 10 to the 9 minus 1, which is equal to 0.24 times 10 to the 8, 0.24 times 10, 1, 2, 3, 4, 5, 6, 7, 8. Which just means move that decimal place over 8 times. So I'm going to have 2, 4, 1, 2, 3, 4, 5, 6. Whoa. That's my 9th term. Woo! So what are the steps? What do we do? What do we do? First we circle this. Let's box it in. It's our answer. So, what did we do first? I think first we took our 2 terms and divided them. So, step 1, divide later term by earlier term. And then step 2 was to find the difference in the number of terms. Or the term numbers. And then this will be your exponent. This is your root, I'm going to say. This is what goes in your little v of your root. Okay, so if you have 5 terms, like a span of 5 terms, then it'll be to the 5th root. If you have, t sub 3 and t sub 9, that would be 6 terms, so you take the 6th root. So divide the later term by the earlier term, that's here. And then find the difference in the term numbers, that's your root. Take that root of that one division. How do I say that? Take the difference in terms, difference in term numbers as root of the quotient of your terms. The quotient of terms. And that's this part. So this will be your root, this will be your quotient. Put it in, that's how you get R. So take the difference in term numbers as the root of the quotient of your terms here, and it's all color-coded. That will be R. So take this, that will be R. So that's step 3. Whew! Step 4 is find the first term by going backwards using division. So you're going backwards using division with R. And then step 5 is to use your formula. So that was a lot of steps. Hopefully you can follow it. We're going to do one more example. But with letters. This is example 19. Same instructions. Find the specified term of this sequence. A b squared. A squared b to the 5th. A cubed b to the 8th. And find the 25th term. So this is different than before. You'll use example 18 a lot in your work. Use those steps and try and follow them. Make sure you do the color coding, because that'll really help. Do it with some kind of colors so you know where the root goes and what goes inside the square root or the 5th root or whatever. Do it. So what we got here? First we got to find r. How do you get from here to here and there to there and so on? So what times a will give me a squared? Well, that will be an a. What times b squared will give me b to the 5th? Well, that will be b cubed. Will that work here? A squared times a will be a cubed. Yeah. And this is multiplication. A, and then b will work. B cubed times 5. Yep, that'll work too. So great, we have r. R equals a b cubed. The first term, that's easy in this case. AB squared. So my formula then is T sub n equals AB squared times R, which is AB cubed, to the n minus 1. And then all we gotta do is plug in with 25, because we want to find the 25th term. So T sub 25 equals AB squared times AB cubed, all to the 25 minus 1, which is the same as AB squared times AB cubed to the 24. Same as AB squared times A to the 24th, B to the 72. And I can continue on by going A to the 25th, because I add exponents, and B to the 74th. A to the 25th, B to the 74th. And that's my 25th term. The end.